Hello world, and in this video we are going to try to make a space shooter game in just 1 hour in the Godot engine. So we've opened the project manager and we're going to hit the create button, and we're going to name it space shooter, and ensure this box is ticked, and ensure you are creating a new folder, and you can use forward or mobile if it is supported. And for this tutorial you can use any of the three renderer. So, and just click on create. You can choose you can just leave the fashion control metadata as git, but I'll choose none. You can pick whatever you like. And now we just have to wait for the Godot engine to open. Also, in this particular tutorial, I'll try to make the game in less than 1 hour. So let's see if we can actually do that. And for those that are getting started, we have tabs. So if you're going to make 3D games, this we have 3D view here. This is where you're going to place all your game objects. If you are making 3D game, if it's a 2D game, we're going to go under the 2D tab over here. And for adding our code, we use the script, and here we can play our game, or we can download assets uh, from other developers online that can help to speed up our project development time. And we can also download add-ons from here. So now let's talk about the nodes that we are going to need. First, we know about our game plan. We need to talk about the game plan. This is going to be a vertical shooter game. So the enemies will be dropping from top, and we're going to be at the bottom, and we can move left or right, and we're going to shoot the enemy by hitting the space bar. So to we need some input map for all this action: to move left, to move right, and to shoot, because that's the only three action we are going to perform. The player is going to perform. And so we go under the project setting, click the project here and click project setting, and we're going to go under the input map, and here we are going to add the new action. This is where we are going to be adding all the inputs. We need the right action, we need the right and left. And for left, you can just use click on the button that you want to assign to the left action. So whenever I press the left button on my keyboard, is going to signal this that the left action is being performed. And I'm going to add another key. If I also press the I move left, so we're just quickly going to do that for the right. So, and for shooting, let's name it shoot, and click add. And now I just press the space bar. So when I press the space bar, this shoot is going to be set to true, that this uh, I'm actually pressing a key from the shoot. And since spacebar is there, so now everything is done. Let's go back to the general. All these are also tabs, just as we've explained earlier with the 2D and the 3D and the script tab and so on. So under the general tab, let's go under the window, and now we're going to change the resolution. So this will be 420, I think 420 times 720. That should make for a good resolution for a portrait game. And under the stretch over here, we're going to change the mode to canvas item. And if this is not as keep the aspect, ensure it has keep. So uh let's just leave everything as it is. So now we need our player over here that can move left or right. And how are you going to create it? Well, we can just add the image, but first we need to think about our game. And our player is obviously going to be shoot. but also the enemies are also going to be coming down, and they are also going to be shooting the player. So we need a way, we need some nodes. In Godot, we use nodes to build up our game objects. So the player can be referred to as the game object, the enemies are also game objects. So we need a way that we can detect when the enemy's bullet hit the player and so on. So the node that we use for that, we use the area to the node so that we can detect when the enemy's bullet hit a particular area. And to do that, we need the area to the node, as I've explained earlier. So area 2D is just a node. Let's name this player. And so to to create where the to create the area that we need to check for when the bullet hits the player. I don't know if you guys probably get it what I'm saying. For example, let's say this is a sprite over here, and let's say I only want to uh the only hitbox, let's call it an hitbox, so that whenever the bullet, let's say the bullet is coming from here, that's when we are going to perform the damage on the player. But let's say the bullet is coming from here, we are not going to do anything. So we can just create a custom collision shape that we can just add the collision shape over here. I'm not sure you guys saw what I'm drawing. We can draw the collision shape over here while ignoring the rest. So that's about the collision shape. And now before we add the collision shape, we are going to add a sprite 2D node, and we use sprite 2D node for adding images to our nodes. So this is just for visual, it doesn't perform any function unless you want to attach a script to it. And what do we use the script for? We use the script for adding extra functionality to a node. So to add a sprite to the sprite to the node, just drag the sprite to the texture property. You can see this properties are in the inspector tab over here, and we have the texture. This is what the texture is by default, and but we can just drag our texture over there. And now I think the texture is a little bit big, but I think for this game that we should be fine. I'm not sure though. So and now we're just going to scale our collision shape. We can arrange the order over here. So what is at the bottom is going to be at the top, like the sprite is going to be at the bottom of the layer. So while the collision shape is going to be on top of the sprite 2D node, as you can see in our 2D view over here. So just draw a shape over here. Where we choose our shape, we choose the new rectangle. We choose circle if that's what you want, uh for your game, or you can choose other collision shapes like capsule if that's what you want. So for this game, I think we're not going to be using any of this. Let's just stick with box shape using the rectangle, and you can just draw a shape. Also, when drawing the shape, ensure that you are not over covering much part of the player. So ensure that your collision shape is not like this, because you want to give players some room for mistakes, so that let's say the bullet is passing through here and it only hits a little bit part of the player, we are not going to damage the player. So now we can save our scene. Collection of nodes in our project can be saved as a scene, so that we can reuse this player node everywhere we want. Don't forget the player node has two node as its children. So the player is the area 2D node, and we have this sprite that displays the player visually, and we also have the collision shape that determines what you are going to be detecting for our area. So this is actually the main area for the area 2D node, and the sprite 2D has nothing to do with the area 2D node. So we've created the player. Now let's talk about moving the player left and right. So to do that, we're going to be attaching a script. But before we continue, I recommend you create a new folder for all your scenes. You can just go to the res just for resources, and under this file system tab, you are going to store all the project files in your project, and just right click the rest and you can create a new folder from there. And I'll just create the script and the scenes folder, and I'll just move the player scene to the scenes folder. And so let's attach a script to the player. So let's navigate to this script and create a new script. So Godot is using the GD script. So first of all, we have two functions. We have function ready, and we also have a function process or physics process. You can choose whatever you like between them, but they are obviously different. Function ready is going to be called once when the node is visible on the screen. For example, when the player plays your game and they hit play, and now the player is on the screen, the function ready is going to be called. That means the node is ready and it's being currently displayed on the screen. But process is going to be called as soon as possible, probably around 60 frames per second, depending on the system or on the system that the game is being run on. So, and the capabilities of the system. So now what are we going to do? We don't need the ready function yet, but in the process function, before everything, we are going to be creating a direction vector that's going to be controlling where we are going to be moving. Let's just set it to vector 2.0. Yeah, wait, yeah, I think let's just leave it as it is. And right now we have our direction that is going to be controlling the movement of the player. We also need the speed, and let's set it to, I don't know, maybe 50. But for now we are just hard coding the variable. Very soon I'll show you how we can apply this, and under the process we can actually test this by adding to the position some values. For example, let's say position.x plus equal to let's say 1. And if I save the scene, and I think there should be some errors over here, but let's just test the game. Okay, our player is obviously moving, but obviously that's not what we want. We also don't want this uh floating dock over here. We don't want it. So right now we have the player moving, but we only want to move the player when we are pressing the input. And to do that, we are going to be using the direction vector. So first of all, we can actually check if actually I don't think there is any need to check. Just see the direction to equal to input dot get vector. And here we no, sorry, I mistake that for uh 4 inputs, whereas I need 2 inputs. To get 2 inputs, for 2 inputs you are going to be using get r6, for example, for left and right only. For 4 inputs, for example, moving up and down, left and right, we are going to be using get vector. So we are going to pass in the negative x, which is for our left, and for negative uh and positive x, we need the right. Don't forget, the Godot doesn't use positive x or negative x, but it's only giving us a positive or negative number. But in our case, that's the x. And also we need to change this to a an integer, and here we can set the position plus equal to the direction times delta to avoid the game being fast in some computer and slow on some computer. So we need to ensure that the position is working correctly on all computers. And no, let's run the scene, and let's check if everything is working perfectly. Okay, we are getting this error. Obviously, that's because a position is also a vector, but we are using an integer. So we have to be changing just the x position. And let's rerun the scene. And now if I press the right, and if I also press the left, we can already saw that this is moving very slow. I just add code it to maybe 300 or 350. Let's just leave it as it is. Now we've created the player scene. We also need the player bullet, but first of all, let's create the enemy scene. The process is going to be the same. Create a area 2D node, name it enemy, and also we need sprite 2D. First of all, let's add the sprite 2D first, and let's add the collision shape. And here, don't forget, we can just drag the sprite that we're going to be using. Except now I want to talk about yet another property. This under visibility, under the canvas item over here, under the inspector tab, where we have this modulate. Here we can use it to apply effects to uh our image, our sprite to the node. We can change the how many red, green, or blue amounts we have in our image. So right now I'm turning down the blue so that there is no blue in the image at all. So we can already see that we don't have any blue. I can turn it full red, and the image is going to become red. So we can use this to change the look of this Godot icon. And obviously, if you are making a game, you are going to be using your sprite, but that's just a simple way to add variations to your sprite. So right now I'm going to make the collision shape to be bigger because we want to give the player the feeling that they are in control. So let's save the enemy scene. Right now we are going to be moving a little bit advanced in terms in terms of our JavaScript. First of all, in this particular enemy scene, we need both uh wait a minute, uh here is area today. I'm just checking why we are not getting this autocomplete that we are getting over here. I really don't know why, so I think that should be okay. Yes. If you are not going to be adding anything to the function, you can just pass like this to tell the Godot engine that this function currently has no function at all. So it's just there. There is no code inside this block of code. So now we are going to be creating an array of colors. Let's name it our colors, and Godot provide us with instead of just hard coding RGB or RGB values, Godot provide us with the color function, and now we can just use this to get the name of colors that we want antique white. I'm just going to add code some colors right here. You can change it to whatever color you want. Okay, web green. And I think if I give it just one more color, I think also I don't really like the antique white, so okay, let's give it pale. So, and under this under the red, don't forget the red is going to be called when a node is visible or added to the scene. To explain it better, when the node is added to the scene root, okay, maybe the scene root is just the main root of the game, of the current scene that is currently running. So when a node is added to it, and it's going to be called, the ready function is going to be called. And so right now we're going to be changing the sprite to the, select it using the dollar keyboard with the sprite name, and we're going to be changing it modulate that we're going to be setting it to colors dot pick random. And so what this does is that it's going to select a random value from all our colors. So we can just save the scene and we can test it if it is working perfectly. Alright, great, it's working perfectly. Right now, don't forget, we also need some other variables like our speed, except our speed is going to be a random number. So to get a random integer from a range, we use the range function. So we want the speed to range from 200 to maybe 300, like that. So we don't really need the direction unless we are going to be making complicated enemies, but we are not going to be making complicated enemies in this game. For this part of the tutorial, maybe we add some variations to the enemy in the future. So right now, under the let's create the direction first of all. Direction, let's name it vector 2, and right now I'm just going to hard coded it to 1, no, 0 and 1. 0 for x, we don't want it to be moving left or right, but we want it to be moving down, and 1 for the y. Don't forget, we are normalizing the value. We don't want the value to go beyond 1, so we can't put 3 here or 4, just want the 1. And we are going to be adding it with our speed so that the enemies are going to move faster a little bit. So let's add it to the position plus equal to our direction. We're adding it to our position times speed times delta. I've already explained this a little bit when we are talking about the player scene. And now let's run the scene. And our player is not falling down. Why is our player not falling down? Let's ensure I get, oh, sorry, this is a process function, not physics. I wasn't even noticing that, but that was a very silly mistake. And now we get the player, the enemy movement. Let's just stop the scene. And now we have our enemies. Our enemies are all set, and but we also need a timer. And the timer node, what we use this for is like, if you want something to be occurring at a specific time, maybe you want something to count down within 10 seconds, but when it reaches 0, starting from 10 seconds, when it reaches 0, you want to perform something, you can use timer for all that sort of functionality. And right now we want to set the wait time to be maybe 2 seconds. It doesn't even matter. We're going to be changing the value from our script. We want to set it to auto start. So we have this, and now what are we going to do with this? Under the under our enemy scripts, we are going to set the uh, choose time. Let's set it to a range. Should it be integer? I think. Okay, let's make it a float. Rounded range from 0.7 to 2.2. Yeah, I think that's okay. So in our ready function, we're going to set the wait time of the timer to be equal to our shoot time, and here we are going to start the timer by calling the start function. And now we can test the scene. Okay, maybe that was a little bit quick, because when the timer runs out, when it is called for that particular sequence, we need a signal. And the signal, just think of signal as the function that is going to get emitted when uh for example, in our case, when the timer runs out, we have this timeout signal that is going to get emitted every time the timer runs out. We can perform actions when the timer runs out. So to check if it's working, we can just print something to console. Let's say shooting player. So let's run the scene again. Okay, it's still a little bit slower, I think. Very a little bit actually. A little bit slower. Maybe setting this to this. Our values will be okay. Okay, I think that's okay. I think that's okay. Yeah, I think that's okay. You can just change the process call back to fixes over here, but I'll just leave it as idle. And now we've created the enemy scene. Right now we are going to be uh kind of speeding things up. We are going to create our main scene, and to create our main scene, let's just add a node as our body, as the root, and let's name it the main. So this is going to be where our game actually goes, and so we can just drag the player scene to the game. And don't forget, we want to position the player scene at the bottom of just maybe right there. We can also place the enemy, but we are going to be generating the enemies. Don't forget, the enemies are going to be dropping down from the top, and then the player have to be shooting the enemies. So we can just put the enemy wherever we like. And right now, let's save our main scene, and we're going to be creating the bullet scene. Still the same process. Area 2D, let's name it player bullet, or if you like, just name it fully player bullet. And we need our sprite 2D, and we also need our relationship 2D. And let's save. Okay, now that we've saved our file, we are going to create the sprite 2D. Under the sprite 2D, we're actually not going to be using the Godot sprites, but we can use it if we want, but we are not going to be using it. Rather, we'll be using the gradient texture over here, and we can just drag around to scale the texture. But I'm actually going to click it, and we're going to change the width property. We're going to change it to 16, and we are going to reset the position under the transform, and right here let's reset the scale, and we are going to scale it. um, I'm thinking about, let's change the width, change it to 8, and let's scale the y-axis. Right now if I scale, it's going to be scaling in all direction, and we don't want that. We want to scale on the y-axis alone, so I can just unlink the scale properties, and now I can scale the y-axis alone. Maybe scale it I don't know, maybe 12 times uh, 24. Yeah, that's too much. Let's go with 20 for now, and save the scene. And under the gradient property of the texture, you can change the color of the gradient. For now we just change it to white, pure white, or let's change it to gray. And if you want to select the same color, you can just click on these recent colors, and we're going to click part of the recent colors, and we can see that we are now using this gray color. So we are going to be creating using this same process for the enemy bullets. Right now I'll just create the collision shape, and also right here ensure that the collision shape is a little bit bigger, because this is the player bullet. And now let's move on to the enemy bullet. Still the same process, create the area 2D, name it enemy bullet, and we need a sprite 2D, and we also need a collision shape. Under the sprite 2D we are going to follow the same process. Gradient texture, the width is going to be, I'm going to use 10 for this one. I'm using 8 for the player bullet and 10 for the enemy bullet, so that the enemy are going to look a little bit scarier a bit. So let's scale it on the y axis. Let's set it to maybe 21, I think. uh, Save the scene, and also add the collision shape. We are going to be using the same rectangle, but right now we are going to make it a little bit smaller than it actually was, and yeah, I think that's okay. And we are going to make it red to symbolize danger, I think, so that the player knows that this is danger, obviously. And also I think I'm going to reduce the value to maybe 70 for both of them, both of the colors to 70. Let's say we want to add in more gradients, you can just drag it and just click anywhere. I'm going to add another color to our gradients, but and we can right click to remove the colors. So now we have the enemy bullet and the player bullet. For the enemy bullet, let's attach a script to it, and right now we only need the direction vector. Let's set it to vector 2, and since the enemy bullet is going to be coming down, there is a simple note I want to make, and that's this is our origin over here. Our origin is over here. I don't know if you guys are seeing the little dots over here, but if you open the Godot engine, you're going to be seeing this same little arrow, and that's the origin as 00. And as we move down on the y-axis, as we move toward downwards on the y-axis, our y is actually going to be increasing, and as we move up, our y is going to be decreasing. So what this means is that since the player bullet is going to come down, the y axis is going to be increasing. So in our vector 2, we are not going to change the x axis, but under the y axis we need to change it to 1, and under the process we are going to be adding it to our position. We are going to create the speed very soon actually. So let's set the speed to maybe 200. Again, this is just a basic game. We are going to do the same thing uh, for the player bullets, and as you might have guessed, uh, we only need to change the direction for now. So this is going to be -1 because the player is going to be shooting upwards. And now when the player actually shoots, let's go to the player scene. When the player shoots, where we want the bullet to be coming out from the player position. So first of all, we are going to be load the bullet. So let's name it our player bullets, and we are going to load the scene. We use the load function to load an external scene. Let's load the player bullets, and now we can create as many bullets, as many instances of this bullet scene as we want. So under the process, we are going to check if we just press a key. Oh, sorry. So we have this is action just pressed. We are not going to be using is action pressed because is action pressed is actually going to be called almost every time. So we can just hold down the space bar and the bullet is just going to keep coming. It's not going to stop coming out of the player. So but we are going to use is action just press so that the player needs to keep pressing the space bar to perform the function. And here we are going to pass in our key inputs, the name of the input that we specify in the input map in our project setting, which is shoot. And if the action is just happened, we are going to create the player bullets, and it's going to become our player bullet dot. To create an instantiation of the player bullets, we are going to be using this instantiate method. And now what we can do is we can treat it as its own, as a scene on its own, because is now a scene. We are loading it from this file, our player bullets. We are going to set its position to equal to the current global position plus offset. We are going to define this offset very soon. And now we have to add it to the scene somehow. We are just creating it in our code. We need to add it somehow to the scene. First of all, let's create the offset variable, and that will be a vector 2. Don't forget we are working with a vector 2 over here. On the x-axis we don't want to change anything. On the y-axis let's just go with system first. I want to kind of, okay, the width of our sprite and the height of our sprite is 128 times 128, and I think we have to divide it by 4. So all of this we are going to do in our main scene, because I want it to be a 32 by 32 sprite. So right now we are offsetting it so that the bullet is going to come out from top of here and is going to move upward. So right now we added all of this, we've created the bullet, but we are not adding it to the scene. Now what you might be tempted to do is to add it as the child of the player. But don't forget, child a child inherits properties from the parent. So let's say the player is as this position on the x-axis, and we add the bullet to it. So let's say the bullet is here, the player is there, and let's say we move the player to this side. The bullet that is in this side is going to get moved over here also, and we don't want that. So what we are going to do is we are going to separate the bullet from the player. So what we are going to do is we are going to be adding it to the main. Let's create a node. A node called node is used for grouping things. Let's name it as player bullets. So this is where we are going to be adding all the player bullets, and since they are not going to be moving around, we are not going to be changing anything of this node. uh, I think we are fine with that. So right now we are going to leave the inspector proper tab, and we move to the node tab over here. We are going to change it from signals to group, and now we are going to click the plus button over here, and we are going to add in a group. And what a group is used is we use it for uniquely identifying a node or a set of nodes or group of nodes, so that we can actually use it in our script, in our code. So right now we are going to do exactly just that. We are going to get our tree, and we are going to get the first node in the group called p bullet. And since this is the only node in the group called p bullet, we are going to be getting this node for sure, so we can assure ourselves of that. And we are going to call the add child. The add child is just the same as adding. For example, let's say we are calling the add child, we're adding this collision shape 2D as the child of sprite 2D. What the add child method is going to do is it's going to add it as the child of the sprite 2D. So we can just change it back. Actually, we don't want it to be there. So now we are going to pass in the player bullets, and I think we should be good to go right now. We can test the scene to check if everything is working as we want. Okay, we are getting some errors. Actually, we are getting some errors, and we are going to fix it very very soon. And first of all, what we need to do is don't forget, we need to scale the player down 4 times. The player is too big for now, so we can just scale it to 0.25. And yeah, I think that's fine. Okay, yeah, maybe that's too small. This 0.5. Yeah, maybe 0.5 is okay. I think it should be 0.5 actually, and not 0.25. And under the player, we made a mistake with our offset, and this should be minus 16, not 16. And now we are going to update the enemy scene also. Don't forget, we need to load the bullets first. Let's create our enemy bullets, and I'm going to load enemy bullets. And under this timeout function, we are going to be creating the bullets. And right now we are going to set the position of the enemy bullets to equal to this global position plus, don't forget, we need the offset. So right now we are going to create the variable of our offset variable. And right now everything should be working perfectly, but don't forget, we need another node, enemy bullets, and I'm going to add it to the group of e bullets. If you like, you can rename the group to make it more descriptive, but I think we're okay with shortening it, since this is just uh, a simple game. It's very short game, so I tried are going to be adding enemy bullets. So let's save it and let's run the scene. Okay, everything is working as intended. That's perfect. You also need to scale this, obviously, 0.5, and let's test if everything is working as we want. Okay, the enemy is moving very fast. We don't want that. And the enemy bullet is also moving very slow. The player bullet is also moving very slow. But for now, we are not going to worry too much about that. We are going to create a node, and we are going to name it as timers. And I want to make a point here that if you are making big games, it's much more recommended to organize everything privately, so that all the enemies are going to be under a node that is going to group all those enemies. We don't want to overpopulate the node in our scene. We want it to be more readable, so we can use the node, or a node called node, to organize things. So right now we have the timer node. We're going to add a timer, and here we're going to set the wait time to 0 points, maybe 0.5, one shot auto start. And let's add a script to the main scene. And under the timer function, we are going to connect timeout signal, so that whenever the timer is out, we can perform some function. So right now we need the enemies scene, and here we are going to be adding enemies. uh, so let's say you are making more complicated games in the future, and you obviously are going to be adding maybe pickups that the player can pick up. And I'm going to talk briefly about this, but uh, we are not going to go deeply into that. Global position, let's set it to a vector 2. For our x position is going to be, don't forget, this is a 32 by 32 image, and right here is 0 0, and we don't want enemies to be appearing around here. We don't want it to spawn around here. We want it to spawn starting from the 0 0, but we can just set it starts to 0, and the end of the range to be maybe the end of our width. No, we need to offset it with uh the half of our sprite width. So right now our sprite is 32 by 32, and so we are going to be offsetting it by with 16 by 16 pixel. And on the x position, this is going to become 16, but we are not going to do that. We are going to say 0, um 0 plus, yeah, plus the offset value. And in the y position, okay, sorry, this is going to be a random number, run the range from 0 plus offset to uh let's create a variable called window. We know that our game window is 420 times 720. So we can just say window dot x minus offset, and we're going to do the same thing for the y position, but a little bit different. Actually, we don't need the a random value for y position. Let's just set it to maybe minus 34 or minus 36. So I think we can leave it at this. Okay, we need to create the offset here. Set it to 16, and now we can add the enemy to the scene. um oh, sorry, we can add the enemy to the scene obviously, but I got carried away. Get three dots. We're going to be getting the enemies variable. Let's create a new node, name this enemies. We don't even need to call this get free, because that is a waste of resources of our game. Just use the dollar sign to select the enemy node, so everything should work perfectly as expected. Okay, we are getting, oh, seriously, this is becoming kind of silly right now. Pardon me everyone. Okay, everything is working as intended. Perfect. I think there's a little bit problem here, but we are going to fix it very soon. Right now we have to scale the enemy. The scale, don't forget, is a factor 2, 0.5 and 0.5, and I think that should be fine. Let our main scene, uh, I want to talk about this but very quick. This is actually what we are going to be setting for how we are going to run the project, and this is just what we've been using before, which is just to run the current scene. So when we hit the play, it's going to ask that what's our main scene. So let's just use our main scene for the main scene. Okay, so everything is working perfectly. Also, when we add the enemy to the scene, we have to call the timer does start again. But first of all, we need to set, oh gosh, we need to set this wait time to equal to round uh yeah, round f range of 1 to 2. No, I set it to 0.6 to 1.4, and we can just call the start function, which is going to start the timer again. So the enemies are going to be added to the scene consistently almost every time. So right now, let's go back to the enemy scene, and we are going to be connecting the area entered. No, actually, we're not going to be doing it from here. Let's go to the player bullets. So right here, we're going to be connecting this area entered to our script, and right now we can just check if the player bullet is within the enemy area. If it is, we can just destroy the enemy. So to do that, we are going to check if the area, don't forget we are getting this area uh, value from the function. So we can just check if it's in group enemy, enemies, let's call it enemy. We are going to call the area dot queue free, and we're also going to call the queue free of the player bullets. And what queue free does is that it's going to remove a particular node from the scene. So that's what this function does. Right now we are going to meet some errors because we have not added a group to the enemies scene. So let's add it. Let's name it enemies. And also for the player, I'm going to add in a group. Let's name it player. And right now what we are going to do is the same thing we do for the player bullets. We're going to do it for the enemy bullets. Signals, area entered, and if areas is in group of player, and we're going to call area dot else minus equal to 10, and we're going to uh, delete the enemy bullet. That's because our player is obviously going to have else value, so that we're going to the game is only going to be over if our health is 0. So right now let's test the game. Okay, everything is working as intended. Perfect. Okay, let's not get carried away. The game is still very far from being completed, and right now what we can do is let's go back to the main scene. We're going to be discussing HUD. HUD just stands for heads up display, and think of uh, all the info that is going to get displayed when you are playing the game, but it's not entirely part of the game. For example, let's say the player health. The player is not the player, but is information about the player. For example, score, the player score, or how many bullets is left, does the player have left. So all of these are referred to as the HUD. And to create any HUD, we are going to be making use of a canvas layer node. So let's move it to the top over here. And right now we'll be using, let's talk about two nodes first. First, that's we have the hbox control node, and what it does is that it arranges nodes horizontally, and we also have the feedbox container, and what it does is that it arranges nodes vertically. So hbox arrange node horizontally, and we can use feedbox to arrange node vertically. So right now we are going to be using hbox container, and right now under this little arrow over here, when you click on it, we have this anchor preset. So we have to set it to the top, but we are going to set it to take the full width of the top available. So we can set it to center, take the full width, or bottom, take the full width, but we are going to set it at top, sorry, over here. So right now we need two nodes to display text in our scene. We are going to be using the label, so we are going to add two label. So this is going to be for our health, and the other one is going to be for our score. Under the else, we can just set it to else to equal to whatever we want to set it to, 100 maybe, but I think we are fine with that. Also under the label setting, we are going to set a new label setting. Here we can set this color to equal to green. Yeah, I'm thinking of setting it to green, obviously. Also, I'm thinking of something over here. um I don't know if this is going to work actually, but let's test if it's going to work. We're going to create a value of color. We're going to set it to RGB, or let's create a variable color R, variable color G. No, I don't think this is RGB. I think this is HSV. So HSV, and let's start the age from 100, and the saturation. We are going to just kind of just copy the what we have here, 100. So set it to 100, set it to 100. So this is going to be HSV. Again, I'm not sure if this is going to work perfectly, but we have to try if it's going to work or not. So right now I'm just going to uh, quickly go over this, and what we are just doing here is we are creating a value of we are giving our color the value that we want. So, and under the start function, oh sorry, under the ready function, we are going to set the else dot um, okay, I'm not exactly sure of this, but let's just try our luck. I'm expecting there to be some there will be some sort of error over here, obviously. So, but we still have to try. Oh yeah, that's true. You have to convert all the into a string. Well, we can actually tell if it's working. So right now, let's just add code a color. Let's check if it's actually working. Okay, it's working perfectly. We just have to figure out the color. um I'm thinking of maybe there's Maybe there is a way we can define a color, and there is, but it's still RGBA, and we are looking for HSV. So right now I'm going to print the color. All right. After a quick search, everyone, um, I found this method online that says that we can just call the this function from the color dot from HSV, and we can just pass in the H, the S, and the V. So what we are going to do is we can just remove all of this, since we are only going to be changing the H, the U. So we are going to be using color H, and this is going to be 100. This is also going to be 100. So let's check if it is actually green color. Okay, we are getting a red color for whatever reason. Let's check why you are getting that. Okay, I'm just going to uh try to just normalize the value. Maybe that's what's causing this, but no, we are still getting the same error. Let's change the H a bit, actually, to maybe 200. It's actually not changing at all. Even though we've changed the U, it's still not changing. I really don't know why. So it is still red. Okay, it's exactly what I thought. They are all actually from 0 to 1. The HSV are going to be from 0 to 1. So we still have to divide this by 360, and we have to change this to 1 and 1. So right now, I think the reason is because maybe it is automatically converting it to a float, to an integer. So we can have some sort of errors when we are working with Godot engine. Oh god, still the same. Still the same. Right now I'm going to print it so that we can look at the value ourselves. I can go out what's going on. Okay, that is not looking great from HSV. Let's also print these values. So we still have to we are still going to obviously get to the bottom of the problem, but for now we have to do it like this. So we don't even need all of this actually. So now let us test the same. Okay, we are getting 000, and 200 divided by 360 should not give us 0, but we are getting 0. So we figured out uh, the main problem actually. It still has to be the type conversion. Alright, now we are getting different value. I can also see, I don't know if you guys saw it because it wasn't that big enough. So maybe we should set it to 42, and let's try again. And now I think you guys should see it. Okay, yeah, there it is. We have the health, and we can saw that the color has changed. And the reason is because the reason we are getting the error is because we are not setting both of the values to a float. Even though I'm actually telling the Godot engine to change it to a float, we are still getting the error. So right now we can just delete all the prints, and we can remove the float function over here, and everything should work perfectly. And I'll explain very soon why we are going through all this trouble. Well, that's because we are actually going to be we are going to be doing some things. Let's call the function down below over here. Let's call it player alt. So right here we have we are going to get in a value called e. So right here we can set the color h to equal to e, uh, but let's convert it to a float to avoid some errors. And so we are going to call this again. And now what we want is that as our health reduces, we are going to be moving towards yellow and towards red to signify danger, obviously. And let's just set it to 100. And since we are reducing it from 100 to 0, it should work perfectly. So this is just a little effect that I think we should add to the game. I haven't thought about it before, so let's reduce this to maybe 32. I still think that's a little bit too big. Sorry. And so this is our score. Our score, let's set it to 0. And since we want to we want our score to be at the right, and we don't want it to follow the health. We can just go under this alignment and ensure that the horizontal alignment, we expand it, and also we are going to align it to the end, or more precisely to the right. So this is to the left, this is to the center, and this is to the right. And what it's going to do is it's going to use the space. Don't forget, we are only getting this effect because of the expand. So we have all this space and this space over here, and we are saying move to the right, to the yeah to the right, and that's why we are getting that. And so now that we have this, we can set this color to I don't know, maybe uh, I want it to be a little bit more readable. We can also add in an outline, and I'll just reduce and I try to pick a nice color. You can pick any color you want over here. So we have the score. I also don't like how the tests are overlapping. You can just change I think that should be either of line spacing or paragraph spacing. I don't think it's line spacing. Just not paragraph spacing over here. So right now I'm actually thinking of how we are going to space it, or we can just reduce uh, the outline a bit. So because we don't want to get into some details over here, so I think that's looking good. Our earth also, we can add an outline if we want, maybe a black outline, and as usual we are going to reduce the alpha to make it transparent. And right now let's go back to the player scene, and under our script, under we are going to talk about setters. And what this does is that whenever the value of health changes, we are going to be setting it from a function. So let's create the set health function. This is where we are going to set the set to equal to the function that we are going to call every time the health value changes. So the set health, takes in an e. So the e is the current health. So we have to change the health to equal to the new health value. And right now what we can also do is we can just go to the main, and um, we can call the player health function and pass in the health. So we can say get tree dot get first node in group main dot player health. We're going to pass in health. So right now I think everything should work perfectly, except we have to add the main sent to the group of main. And now let's test everything. We are going to take in some bullets to ensure that the the color actually changes. Okay, the color is actually working perfectly in my opinion, because what's going on is we are not, our height can go more than 0. So we are getting some s value of less than 0. If height is less than 0, obviously we have to call the main group again. I'm going to call the game over. And so what are we going to do when we call the game over? Obviously we are going to talk about that very soon, but first of all we have to create the set health, and we also have to create the set score function. And so the set health and the set let's go back to the script, and the set score function, we have to change the test value of the score and the health. And what we are going to do is just going to set it to health. And don't forget we have to convert the e is a as an integer, we have to convert it to oh silly mistake. We have to do the same thing for the score. And so right now every time we kill an enemy, I think that's taken care of by the player bullet. We have to call the main group, and we have to change the score. We have to add 50 to it. So right now we are quickly going to create a score variable, set it to 0, and the same thing we are going to call in a setter. Should we use the set score already? I just use that, and we just set the score to equal to e, and the same thing for uh well, I don't think there is any need for this for the else, because we can just set out to equal to e. So I think everything should work perfectly for by now. Obviously we don't have the game over function. We have to create one, and when the game is over, what are we going to do? Under our canvas layer, we are going to add in a when you want to group stuffs, we can use the margin container to group nodes together, and we can have greater control over how the nodes that the margin that is inside our margin container is positioned on the screen. So we can position the margin container to the center of the scene, and we can also add margins to the nodes that are the children of the margin container. So we use the margin container a lot when we are creating a game. So to add margins to it, we can just go under the theme overrides, and under the margins we can add margins to our node. For example, for our health and our score over here, I'm quickly just going to add in a margin container. And obviously we are going to be getting some errors because due to this, because of our script. So we have to go to our script, and that's alt. Same thing for the score, and the same thing over here. There are ways we can avoid doing this if we change how we position the nodes in our scene. But since this is just a very simple game and I don't want to go into some more complicated stuffs, we are going to just use that for now. So right now we have to do exactly what we've been doing before. Set this to wide, and right now let's go under the margin container, margin left 10, margin right 10, and margin top maybe 10. Yeah, that looks good, I think. So under the margin container for our game over, we need a label, but first of all we need our VBox because we want to align the items vertically. So this is going to display the text game over, and I've explained all of this. Let's change the color to red. Let's change the font size to maybe 42. I don't know, maybe 52. That looks good. And now we are going to introduce another node called the button. And so this is going to call, we are going to add a text to our button. Let's call this restart. And you can see that it's taking the full width available. You can set it to center itself and to not take the full width available. So this is exactly what we do over here. And what I can actually still do to this is we can change the font size to maybe 32, and we can leave everything as it is. We can change the color. There are different values for the color, and I actually don't want to go over all of this. Also, there is something that I want to explain very quickly, and that's the process. When the game is over, we want to stop everything, but we want the player to also be able to click this restart button. So under the margin container for the game over, we have to set the process, instead of to inherit the process mode to inherit, we have to set it to always, so that when the game is over, this is still going to be running and it's not going to be paused. So inherit is actually when the game is over and we pause everything, it's going to pause. But when we set it to always, it doesn't matter whether we pause the game or not, this node is going to be active always. So right now we have the pressed for the button. Whenever we press the button, this function is going to get called, and what we are going to do is we are just going to reload the current scene. We have the reload current scene method from the get tree, and what that does is that it's going to reload the current scene. And so when the game is over, as I've said, uh, I think that should be get tree dot pause. We are going to set it to true, and also we are going to set the margin container. You can just set it to show, because when the game starts, we're actually going to hide it. We're going to hide it, but when the game is over, we are going to show it like this. And when they press the when they press the restart button, we are not going to saw any of this again. So let's just hide it for now. So this is what we use to hide or show a node. So I think everything should be working perfectly by now. We can still get some errors. We are not getting any errors for now. Okay, let's try to lose on purpose. We can see that as we approached 0, the health color changes to red, from green to yellow to red, and we get this game over screen. And when I press on restart, you can see that everything is paused. All the player and the enemies that are moving, they are all paused. But when I click on restart, we are going to start the game again. But when I press left and right to move, we are not getting anything. And why is that? Don't forget we are calling this get tree dot pause over here under the game over. But when the game starts again, we are not resuming the we are not telling the tree to start running again. So it's just going to reload it. It's not going to perform any function because we've already paused it. So what we are going to do is we are going to we are not going to we are going to set its pause value to we are going to set its paused property to false. And right now let's test the game again. Okay, let's lose the game on time. Let's just lose the game. Okay, and let's hit on restart. And yes, we now have a fully functioning game and not that much functionality. You might have guessed there's a lot of tweaking that we need to do, but we've created a game and using no sprite at all, which is absolutely fantastic. And we can see that our player can move beyond the screen bound, and to do that to avoid that we can use the clamp function. So right now we are at the stage of fixing stuffs. We've already finished the game. We have a playable game, but we have to make the game more enjoyable. There are so many errors in the game, and so what can we do to avoid the player moving to beyond the screen bound? What you're going to do is you can use the clamp function. So let's set the position dot x to equal to the clamp. So right now we are going to clamp in the position dot x. What's the main value of the position dot x? It's going to be offset dot, oh god, we're not going to be using offset. This Let's create a variable offset bond x. Let's set it to 16, and yeah, we're going to set it to 0 minus no 0 plus offset bond x, and this should be let's just hard code it for now, minus offset bond x. But we can just create the same variable window vector 2 just in case you want to scale the game in the future. So to equal to this, and just set this to window.x. And if we've typed everything correctly, we should be preventing the player from going outside the scene. Okay, we've prevented everything, but we've not prevented everything at all. So there's still some errors. Why are we getting this? It's obviously from the offset bond, but why exactly are we getting this? I actually don't know, but I'm actually thinking of something over here. I'm thinking of the way we are shooting. The reason why we are not getting the correct value, we are not shooting at the top. Is it because of that? Yes, I think I think our sprites are still 64 by 64, so this has to be 32. Also, we have to change our offsets. Where did we create the offset? I think for the enemy, that's to be 32. So yeah, I think that's all about it. All right, let's also fix some other things. Okay, let's check if everything is working perfectly. When I move to the left of the scene and to the right of the scene, okay, everything is working perfectly. When I lose, everything is working perfectly. Great. Right now we can add in a background color. What are we going to use? We can use a uh, texture rect, and we can set it to full width and height by clicking this under the anchor preset full rect. So here we can set the image to texture gradient, and here we can set in our colors. So let's just make it red. Let's make it black, and maybe that's good. I don't know. Maybe let's make it a little bit gray. So let's check the game. Okay, right now there are so many errors in the game. I just remembered of something. Um, but before we dive deep into that, let's change the speed of the enemy bullet to maybe 300, and the player bullet to maybe 350. And right now, what we are going to do is we can check under the process. I can check if the position dot y is less than minus 32. And what are we going to do with that? We can just call the kill free to remove it, and the same thing for the enemy bullet. Okay, right now we fixed some optimization issues, because when the bullets, both the player bullets and the enemy bullets, are not in the same anymore, we should just remove them. There are better ways to do this, but this is a basic intro to Godot, and we don't want to dive deep into all the quacks of game development and so on like that. So we are just hard coding most part of the game, but right now we fixed some optimization issues. The same thing for the enemy. Can check if the enemy position. Actually, what you are going to do is if the enemy position is uh, greater than 720 plus 64, and we're going to call the player. We're going to reduce the health of the player by 5, and we're going to remove the enemy. So if you are not guiding the player very well and you let them be past you, and that is going to cost a 5 health of the player. So let's say I'm not playing any of them. We can already saw it in action. So this is looking so good. I like this already. So we can even talk about lighting and so on like that, but we're not going to talk about it in this game. So what else do we need to do? The way the players are shooting, the enemies are shooting actually. We don't like that. We obviously don't like that. So let's see, maybe 0.8. Okay, that's looking good. Okay, ladies and gentlemen, I think the game is set. So you can have fun with the game. You can add more stuff to the game. Maybe add pickups, maybe health pickup, so that you know. Let's say uh, also you can make it more challenging. Maybe the speed of the player got increased over time. Um, okay, that's it for the game, ladies and gentlemen. I very happy for you joining the tutorial, and I hope you guys have gained a thing or two. In the future, maybe I can add some part of the tutorial to add effects to the game, maybe sound effects and or visual effects, or adding juice to the game. We can also talk about exporting, how we can export our game. But for now, I think the game is ready, and we can finally say that we've created a space shooter game in Godot engine. So give yourself a pat on the back, and thank you so much for watching, and we'll see you in the next video. And if you found the video helpful, please give us a like, comment on what you think about the game, and what other videos or tutorials you would like to see in the future. And also you can consider supporting us on Patreon. Thank you so much. Bye.